6.2, factoring trinomials with an understood 1 in the first part. Factoring means make a multiplication problem. Let's look at an example of multiplying, look at the answer, and see how to come up with a question. X plus 3 times x plus 5. FOIL. X times x, x squared. Outside, x times 5, 5x. Inside, 3 times x, 3x. Last, 3 times 5, 15. Add your like terms. 5x plus 3x is 8x. Note that the end term has 15, and 15 is 3 times 5. Note that the middle term has 8, and 8 equals 3 plus 5. So you can see our numbers, 3 and 5, multiply to 15 at the end. They add to 8 in the middle. And that works only because we have x and x. Because your outside is 5 times x is 5x. Your inside is 3 times x, 3x. That's why the 5 and 3 add to the 8 in the middle. Trinomials with an understood 1 in the first part in front of x squared. Example, x squared plus 8x plus 12. You will find two numbers that multiply to the last number and add to the middle number. Work on multiplying to the end first because that is quicker. It's quicker to go through the list of what multiplies to 12. Okay, now note this only works if you have x squared, 1x squared. Example 1, factor x squared plus 8x plus 12. What multiplies to 12 and adds to 8? 6 and 2. So we have x plus 6 times x plus 2. The first terms are x, since x times x is the x squared. Check by FOIL. First, x times x, x squared. Outside, x times 2, 2x. Inside, 6 times x, 6x. Last, 6 times 2, 12. Okay, what about if we said what multiplies to 12 and adds to 8, 2, and 6? Does this come out to be the same or different? Let's see. Let's FOIL. X times x, x squared. X times 6, 6x. 2 times x, 2x. Last, 2 times 6, 12. 6 plus 2 in the middle adds to 8. It comes out the same because 6 plus 2 and 2 plus 6 are the same. Example 2, factor x squared plus 9x plus 20. X plus 5 times x plus 4, since 5 and 4 equals 9, 5 times 4 is 20. What multiplies to 20 and adds to 9? Always multiply to the end, add to the middle when you have 1x squared. You can also say x plus 4, x plus 5, because 4 and 5 also adds to 9 and multiplies to 20. Example 3, factor x squared plus 6x plus 5. What multiplies to 5 and adds to 6? 5 and 1. So x plus 1 times x plus 5, or the reverse of it. Example 4, factor x squared plus 10x plus 21. What multiplies to 21 and adds to 10? 7 and 3. So x plus 7, x plus 3, or the reverse, x plus 3, x plus 7. Example 5, factor x squared plus 10x minus 24. What multiplies to negative 24 and adds to 10? Positive 12 minus 2. 12 minus 2 is 10. 12 times negative 2 is negative 24. So x plus 12, x minus 2, or x minus 2, x plus 12. The 12 has to have the positive because remember, when the signs are different, you take the bigger one, and that 10x is positive. So the bigger number 12 has to be positive. Example 6, factor x squared minus 3x minus 40. What multiplies to negative 40 and adds to negative 3? Negative 8 and positive 5. X minus 8, x plus 5, or x plus 5, x minus 8. Okay, that minus 3x in the middle is negative, so that means our bigger number 8 needs to be negative. Okay, because to multiply to negative 40, you need a positive times a negative. Example 7, factor x squared minus 8x minus 12. What multiplies to negative 12 and adds to the understood negative 1? That would be negative 4 and positive 3. X minus 4x plus 3, or x plus 3x minus 4. To multiply to a negative, you need a positive times a negative. Example 8, factor x squared minus 7x plus 12. What multiplies to positive 12 but would add to negative 7? Minus 4 and minus 3. Because remember, the signs are the same, so you add and keep the sign. X minus 4, x minus 3, or x minus 3, x minus 4. Example 9, factor x squared minus 5x plus 6. What multiplies to positive 6 but adds to negative 5? Negative 2 and negative 3. Remember, when the signs are the same, you add and keep. We need the negative times the negative to equal positive 6. But we need negative 2 and negative 3 to add up to negative 5. So x minus 2, x minus 3, or x minus 3 times x minus 2. Example 10, factor x squared minus 10x plus 25. What multiplies to positive 25 but adds to negative 10? Negative 5, negative 5. Note that this can also be written x minus 5 quantity squared, because it's something times itself. But either form is correct because either one of those multiplies correctly. Factor x squared plus 9x plus 20y squared. This time we need y times y to get y squared in the last term. We still want to multiply to 20 and add to 9. So this would be x plus 5y times x plus 4y. Or x plus 4y times x plus 5y. Because 5 plus 4 is 9, 5 times 4 is 20. FOIL to check. First, x times x, x squared. Outside, x times 4y, 4xy. Inside, 5y times x, 5xy. Last, 5y times 4y, 20y squared. Combine like terms in the middle, order letters alphabetically. X squared plus 9xy plus 20y squared. Example 12, factor x squared plus 10xy plus 24y squared. We need y times y to get y squared at the end. What multiplies to 24 and adds to 10? 6 and 4. So x plus 6y, x times 4y, or x plus 4y, x plus 6y. We need 6y times 4y to equal the 24y squared. Example 13, factor x squared plus 7x plus 3. What multiplies to 3? 3 and 1. Nothing else. Do these add to 7? No. This is prime. This means there is no multiplication problem other than 1 in itself. So we say that is prime. Example 14, factor x squared plus 12x plus 15. What multiplies to 15? 1 times 15, 5 and 3. Do either of those add to 12? No. This is also prime. Okay, no, they don't have a common factor because that first thing is just x squared. All of these trinomials were an understood 1 in the first part. What multiplies to the end adds to the middle. Nothing multiplies to 15 and adds to 12. Prime. That's the end.